So this is a hard question, and I will start by rewriting this so that I can compare it with that expression, which is a multiple of 35. So that gives you a clue that we have a 35 here as well, and 6 squared we know is 36, so that's close to 35. So there is some relationship here. So I can rewrite this as 6 squared to the power of n minus 1 minus 35n. Now this is 36 to the n, and I can also write 1 as 1 to the n. The reason I'm doing this is because there is a property that a to the n minus b to the n is always divisible by a to the minus b. Sorry, a minus b. So that means that this 36 to the n minus 1 to the n is a multiple of 36 minus 1, or 35 times some k. So that piece is always a multiple of 35. This is a multiple of 35. That means this is always a multiple of 35. We also know this is also a multiple of 35. So now we just have to see which of these categories is satisfied. So we can generate these numbers to kind of see a pattern. So when n is equal to 1, b has 0, then if n is 2, then it would be 35, then 70. So all the multiples of 35, so 105, 140, so on and so forth. If you look at that for n equal to 1, this is 36 minus 36, so that's 0, which is here. And then if we do n equal to 2, this would be 6 to the 4 minus 35 times 2 minus 1. So 6 squared is 36. I mean, you can at least use the calculator, just repeatedly multiplying that. That's 1296 minus 70 minus 1, which is 1225. And we already know that it has to be divisible by 35. We were just trying to see how much the numbers jump. So this is divisible by 35, we'll get. And the next one would also be divisible by 35. But you'll see that the multiples of 35 would be making these jumps. So clearly not all multiples of b are present here, but every multiple of in a, or every number in a, is present here. And that was already established with this result, that they're both, that a is a multiple of 35. So if I look at the answer choices, at least one member of A is not in B. That's incorrect, because all members of A are multiples of 35, and therefore they're here. Every member of B is in A. That's not true, because, for example, 70 is not there. Every member of A is in B. That is correct, and at least one member of B is not in A. For example, 70 is not, as we're jumping from 0 to 1225. So that seems correct, but let's go over this one as well. Neither every member of A is in B, nor every member of B is in A. So this part is true, but that's actually not true, because every member of A is indeed in B. So that one is also out. The answer is B.